Fine. So screen is visible, right?
Yes, sir.
Visible. Okay, fine. So yesterday we have done up to this. Okay, fine. Uh, I think we have done up to what? Borans we have done, and I think that shape of the molecule also we have done this, no? Just a minute. Boran. Okay, got it. So done up to this. Fine. So suppose next we have number 3 we have this CP4 CO4 B2 H6. Okay, try to do it. So you have to just tell me, yeah, what is it? Clozo, nido, arachno, what is it? Okay, so this kind of thing we have not done. Okay, so here we will do isolobal analogy. Okay, that we will do separately later also. Okay, so write down here that isolobal analogy. Okay, so basically here we have two things. One is our transition metal. Okay, transition metal. So if you see this cobalt, okay, iron, okay, nickel, these copper, these are all your transition metal. So first of all, see total how many electrons are there. So if you have 4 cyclopentadienyl, so that means in neutral method you can calculate that you have 4 into 5. Okay, uh, 20 you are getting from here, or you can do okay, no need to do like that, otherwise it will be difficult. You just see what you have, CP4 CO4, right? So together I can write down like this, CpCO whole 4, then suppose you have here B2H6, right? So CpCO whole 4 B2H6. Now this cobalt is what? This is a transition metal, right? So if you see here, Cp into CO, right? So cyclopentadienyl is donating 5 electrons, and from cobalt center you are getting 9 electrons, right? So if you add them, 5 plus 9, you are getting how many electrons? 14 electrons. Okay, so cyclopentadienyl is donating 5 electrons, and cobalt is donating 4 electrons. Now keep in mind, for isolobal analogy, if you are getting 18 electron, okay, so for main group element, okay, main group element it will be equivalent to your 8. If you have 17 electron here, you are getting from transition, so for main group it will be 7. If you are getting 16, so it will be 6. If you are getting 15, it will be 5. Why you are getting 10 electron less here? Because in transition metal you have extra 10 d electrons, that all of you know, right? When you are considering transition metal, so that means you have extra 10 d electrons. Okay, so if I consider with if I compare with main group element, so basically 18 electron in transition metal, that will be equivalent to your 8 electron in main group. Similarly 17 will be equivalent to 7, 16 will be equivalent to 6, 15 will be equivalent to 5, like that it will continue. So 14 will be equivalent to 4. So now if you see here, you have CpCO, right? So 5 plus 9, I am getting 14 electron. So now can you tell me like with which you can compare it? Main group you have to consider. So we are doing boron derivative, right? Boron derivative. Yeah. So if you consider BH, okay, BH. So boron, valence electron of boron is 3, and for hydrogen it is 1. So you are getting 4 electron. So that means the CpCO unit, okay, this CpCO unit is actually equivalent to what? Your BH unit. Okay, this CpCO unit is actually equivalent to your BH unit. So you can write down here that this thing, you can write down that BH whole 4 B2 H6. Now do it. Now do it.
Nido, sir.
Nido, right? So altogether I am getting what? B6 H10, right? B6 H10. If it releases 4H plus, so that means I am getting what? B6 H6 4 minus, which is actually your what? Nido. Okay, which is actually your Nido. Got it? How to do? Clear?
Yes, sir.
Okay. Now next, this example you guys will do, huh? You guys try. So you have cobalt, then you have here B4 H8, then you have eta 5 C5 H5. Do it. Then tell me what you are getting.
Sir, Nido.
Nido you are getting, right?
Yes, sir.
So cobalt means how many electrons? 9 electrons, and eta 5 C5 will give you 5 electrons. So again 9 plus 5 is equal to what? 14. So this CO eta 5 C5 H5, they are donating you what? How many electrons? 14 electrons. So again this is equivalent to your BH. So BH means you will have 4 electron. So you have BH here. Okay, with this BH I have B4 H8. So if I add them, what I am getting? B5 H9, right? B5 H9. So if it releases 4H plus, then what we will get? B5 H5 4 minus. So again 4 minus means what? Nido. Okay. Okay, now this one, number 5. Suppose you have this B3 H7, then you have here Fe CO whole 3 whole 2. Do it.
Nido.
Nido you are getting, right? So again if you have to see, so iron is donating 8 electrons, and from 3 carbonyl you are getting how many electrons? 6 electrons. So this FeCO whole 3, okay, this FeCO whole 3 you are getting 14 electron from here, which is again equivalent to your what? BH unit. So I can write down here that BH whole 2, right? This FeCO whole 3 that I can write down, actually I can replace with BH whole 2, and apart from that you have already B3H7. So if I add them all, what I am getting here, B5H9, right? So again that thing I can write down, B5H5 4 minus, okay. Don't make it square, huh? Don't do like this 14 square like that, okay. If you are getting 14 electrons, so just replace with BH unit because it has 4 electron. So you have to do BH whole 2, so that means B2H2, okay. So overall you have what? B5H9. So again you are getting here nido, okay. Again you are getting nido from here. Clear? Any doubt? Any doubt? No, right? Okay, just a minute, actually. Okay, fine. So now we will compare the shape, okay. So write down here n, okay, n value, and here we will see the shape, okay. What is the shape? So suppose n value is 4, suppose n value is 4, then the shape will be tetrahedral, that you already know, okay. Suppose the n value is 5, then the shape will be what? TBP, trigonal bipyramidal, okay, that also you know. If it is 6, then it will be what? Octahedral, okay. If it is 7, then it will be what? Pentagonal bipyramidal, PBP, okay, pentagonal bipyramidal. So these are the 4 values already you know. So 4 belongs to tetrahedral, 5 TBP, 6 will be octahedral, and 7 will be pentagonal bipyramidal. So up to that all of you know, okay. Now write down, if you are getting n is equal to 8, n value if you are getting 8, so that time the shape will be your dodecahedron, okay, dodecahedron, okay. If you are getting 9, so that time it will be your tricapped, trigonal, tricapped trigonal prism, okay. If this value is 10, then it will be tricapped square antiprism, okay, tricapped square antiprism. If this value is 11, then it will be your octadecahedron, okay. And if it is 12, then it will be your icosahedron, okay, icosahedron. So these are the structures you have to now know. So up to pentagonal bipyramidal all of you know. If it is 8, then it will be your dodecahedron. If it is 9, then it will be tricapped trigonal prism. If it is 10, then it will be tricapped square antiprism. If it is 11, then it will be octadecahedron, and if it is 12, then it will be your icosahedron, okay. Clear? So you have to just check the n value. N value means what? This value. Suppose BNHN, okay, BNHN whole to the power any thing. Suppose you have 2 minus. So this n value you have to check. Okay, this n value you have to check. Clear? So for example, suppose you have this b5 h5. Okay, b5 h5, then you have here 6 minus. Okay, so if you have b5 h5, so that means what? N value is 5. Okay, n value is 5, so the shape will be what? TBP. The shape will be your TBP. Okay, now suppose you have number 2, you have this c2 b4 h7 minus. Okay, find out the shape what you are getting here. c2 b4 h7 minus.
Octahedral, sir.
Hmm?
Octahedral.
Octahedral, right? So this carbon I have to replace with BH, right? Carbon will be your BH. So this is becoming BH whole 2. Then you have what? B4H7, and here you have negative charge. So already you have here 2 boron and 4 boron from here. So I am getting B6. Okay, 2 hydrogen here and 7 hydrogen here. So B6 H9, what? Negative charge, and you have to release 3 hydrogen from here. Okay, so then only you will get your n value, because this value you have to make it similar, right? So b6 h6, so already you have a negative charge. If it is releases 3 protons, so ultimately it is becoming 4 minus. So n value is becoming 6. When n value is becoming 6, so that means it is your what? Octahedral. Okay, okay, good. Now try this one, number 3. Suppose you have this Me C3 B6 H5 whole 2 minus. Try this one.
Tricapped square antiprism.
What you are getting?
Tricapped square antiprism, sir. N is equal to 10.
N is equal to 10 you are getting.
Yes, sir.
Okay, so this methyl will equivalent to what? Methyl methyl will donate how many electron? So if you see, carbon has 4 valence electrons. Already carbon is making 3 covalent bonds with 3 hydrogen. So that means only 1 electron left, right? So CH3 is donating only 1 electron. Okay, so I can say this is equivalent to what? This methyl is actually equivalent to your hydrogen. Okay, because hydrogen also donates 1 electron. So from this methyl you are getting hydrogen. Okay, now you have C3. So carbon, you know, carbon you have to replace by BH unit, right? Carbon is 4, BH is also 4. So carbon you have to replace by BH unit, and whole 3 you will get here, whole 3. Then you have B6, H5, okay, whole 2 minus. So now if I add them, so I have B3, B6, so that means I am getting B9. Okay, B6, B3 I am getting B9. And hydrogen, how much hydrogen you are getting? 5 from here, 3 from here, 1 from here. So 5, 3, 8 plus 1, 9. So B5H9 2 minus, right? All of you are getting this? B9H9 2 minus. So N value we are getting 9. So if you are getting N value 9, so that means what? It is tri-capped trigonal prism. Okay. So this value, this structure you will get this tri-capped trigonal prism. Okay, that will be the shape. Clear?
Yes.
Okay, fine. Now suppose you have this C2, B4, H6, platinum, P, Et3 whole 2. Find out this.
Sir, pentagonal bipyramidal, sir.
Pentagonal bipyramidal you are getting. So this C2 I have to replace by BH. Okay, so it is becoming BH whole 2. Then you have B4 H6. Now the question comes about your platinum. So PT PET3 whole 2. So platinum will give how many electrons? 10 electrons, right? Nickel, palladium, platinum, this group. So you will have 10 electrons from your platinum center. And if you have PET3, so PET3 means this ligand, right? So already it is making 3 bonds with 3 ethyl. So 2 electrons left here on phosphorus. So those 2 electrons it will donate. So that means phosphorus is donating 2 electrons. So you are getting overall 2 into 2, So again you are getting 14 electron for this compound, which is also equivalent to what? Which is also equivalent to your BH. Okay, so this P83 whole 2, this whole thing is actually equivalent to your what? BH. So if I add them, what I am getting? So here already you have 4 2 6 1 7, so you have B7. Okay, and hydrogen is what? 2 6 8 1 9. So B7H9, it will become what? B7H7 2 minus, right? B7H7 2 minus. So it is closo. Okay, closo. And if I talk about the shape, so n value you are getting 7, so it will be your pentagonal bipyramidal, PBP. Okay, good. Clear? Any doubt? Any doubt? Clear?
Yes. Yes, sir.
Okay. So now write down isolobal analogy. Okay. So now we will discuss it broadly. Okay. So isolobal analogy. So suppose I have this CH3, CH3. Okay, this is your ethane molecule, all of you know. Now write down here this side fragments. Okay, so if I break this molecule, what you will get? CH3 dot. Okay, homolytic cleavage we will do, homolytic cleavage. So what we are getting? CH3 dot. Okay, now suppose you have this molecule CO whole 4 Fe, you have double bond here Fe, then again you have CO whole 4. So the fragment from this molecule, it will be your Fe CO whole 4. Next you have suppose CO 4 CO whole 12. Okay, CO4 CO whole 12. So the fragment will generate from here this CO whole 3. Okay, you can see if you have 4 cobalt center and if you have 12 carbonyl, so that means per cobalt you will get 3 carbonyl, right? Here you have 2 iron center and 8 carbonyl center, so that means per iron you are getting 4 carbonyls. Okay, so that is actually your fragment. Similarly, suppose you have ethylene molecule. Okay, ethylene molecule. So you have 2 carbon and total 4 hydrogen. So that means per carbon you are getting how many hydrogen? CH2. So the fragment will be your CH2 from here. Okay. Okay. So isolobal analogy concept you will get from here. So you can write down clearly here that one line, just write down that the two cluster fragments, the two cluster fragments are isolobal. Two cluster fragments are isolobal if they have same frontier orbitals. Okay, same frontier orbitals. Okay, so the two cluster fragments are isolobal if they have same frontier orbitals. Now what is frontier orbital? So that we need basically separate understanding for that. Okay, so you can follow one book which is your crab tree. Okay, sorry. Okay, crab tree. That is a very popular book for your organometallic chemistry. So there you will get better understanding, because they will have, what I can say, that pictorial representation they have. So they have properly shows you. Okay, so that is actually not possible here. Okay, so you can refer this book crab tree. Okay, there you will get. So next, write down characteristics. So what are the characteristics we will get? So number one, write down that both the fragments, okay, both the fragments have same symmetry. Okay, both the fragments have same symmetry. Okay, number two, write down that same number of electrons available for cluster binding. Okay, same number of electrons available for cluster binding. And number three, approximately same energy. So suppose you have a compound, okay, suppose you have ethane compound. Now when you are getting CH3 dot and CH3 dot, so that means those are the two fragments you are getting. Okay, so those two fragments should have the same symmetry, they should have same number of electron, and their energy also should be same. Okay, then only we can say that they are isolable to each other. So this is basically, I can say, the physical background of this. Okay, but we will not consider this because we will use some trick to identify the isolable. Okay, because in exam we don't have that much time that we will find out the symmetry, then we will count down the electron, then we will find out energy. Okay, so that much time you will not get. Okay, so we will use some trick, and by that trick it will be easy to find out whether it is your isolable or not. Okay, clear?
Sir, what energy are they considering here?
Energy means your it can be different types of energy. Basically they will consider here like what I can say, suppose you have CH3 dot and another you have CH3 dot, right? So if they combine with each other, so that is what, that is your binding energy. So that they are actually considering. Okay, so suppose for one, you have one H dot, another you have H dot. Okay, so these two species should have the same energy, that they are actually trying to say. Okay, now
Yes.
you know already that if electronegativity increasing, so that time the energy will decrease. Okay, so like that you have to check. So basically they are trying to say that these like, suppose what we are doing, that carbon we are doing carbon we are making equal with BH unit, right? So we are saying that carbon is isolable with BH. So they are saying this actually. So the carbon energy and boron energy should be approximate. So approximately what? Approximately means not exactly equal. It should be close enough. Okay. So if you see boron is your 5 and carbon is your 6, right? So next to each other. So that means the energy will be close enough. Okay, close enough. Clear?
Yes.
Okay. So now it will be easy enough. Okay. So write down case 1. Okay, so case 1. So write down here transition metal. transition metal, and you will get main block. Okay, main block elements you will get here. So that thing already I have shown. If you have 18 electron, for main block it will be 8 electron. If you have 17 electron, it will be a 7 electron. In transition metal, if you have 6 electron, in main block you have 6 electron. In transition metal, if you have 15 electron, in main block you will have 5 electron. Okay, if you have 14 electron, it will be your 4 electron, like that. Okay, so for example, we have done, suppose you have PT PPH3 whole 2. Okay, PT PPH3 whole 2. So how many electrons we have? From platinum center we are getting 10 electrons, and this PPH3 will donate 2 electrons. So each PPH3 is donating 2 electrons. Altogether they are donating 14 electrons. So that means this 14 will be isolable with your 4 electrons. So that means I have to replace this unit with BH. Okay, I have to replace this PT PPH3 whole 2 unit with BH. Okay, so that's actually they are saying. Done, this one done. Like that it will continue. Okay, 13 electron will be 3 electron, 12 2, 11 1. That's it. Okay, 10 will be 0. Okay, if you have 10 electron in transition metal, so that is not equivalent to anything. Done.
Yes, sir.
Okay, now number 2, write down case 2. Case 2. Okay, so here we will consider transition metal with transition metal. Okay, transition metal we are comparing with transition metal. So suppose you have 18 electron here, so that will be absolutely equivalent to what? 18 electron. 17 electron, it will be also equal to your 17 electron. If you have 16 electron, that will be also your 16 electron. If you have 15, so here also it will be 15. If you have 14, so here also it will be 14. Okay, like that it will continue. Okay, like that it will continue. So for example, suppose you have CpCO unit. Okay, this unit CpCO. So for cyclopentadienyl you have 5 electrons, and for cobalt you have 9 electrons. If I add, what we are getting? 14 electrons we are getting from here, right? If I have this NiCO whole 2, so that means for nickel you are getting 10 electrons, and from this carbonyl center you will get also 4. So that is also 14, right? So this CpCO is actually equivalent to this unit also, NiCO whole 2. You can replace them. Okay, done. Understood. So in first case we are comparing transition metal with main group elements. In case 2 we are comparing transition metal with transition metal only. Okay, clear? Done. Should I proceed? Done.
Yes, sir.
Okay, now next is your case 3. Case 3. So in case 3 basically we will compare both. Okay, both means main block. Okay, so here we will compare main block with main block only. Okay, main block elements with main block elements only. So suppose you have 8 electron, so it should have also 8 electron. If you have 7 electron, it should have 7 electron. If you have 6 electron, it will have also 6 electron. Okay, if you have 5 electron, it will have also 5 electron. Okay, So basically this carbon is isolable. Okay, the isolable is actually representing like this. Okay, this is the symbol of your isolable. Okay, so this kind of arrow you have to use and just make a sphere here. So this is your isolable symbol. So carbon is isolable with what? BH unit. Okay, similarly I can write down this nitrogen. This is isolable with what? This is isolable with your BH2 unit. Okay, clear? Any doubt?
Clear, sir.
Clear, right? Sampriti, clear?
Yes, sir, clear.
Clear, right? Okay, fine. Now I am writing some table. Huh? So within this table you will get all the things. So suppose you have CH. Okay, so if you have CH, how many electrons you will have? 4 plus 1. How many electrons? 5 electrons you have, right? These are your main group. So now suppose you have this CO whole 3. So cobalt has how many electrons? 9. And for 3 carbonyl you are getting 6 electron. Okay, so you will get here 15 electron. So see, this is your transition metal. This is not your main group. If you have cobalt, so this is your transition metal, right? So here 15 electron will be isolable with your 5 electron of main group system. Okay, similarly I can write down here this also, that manganese, and here you have CO whole 4. Okay, so manganese you will get how many electrons? 7 electrons, and from 4 carbonyls you will get 8 electrons, which is also equivalent to what? 15 electrons. So that means this MnCO whole 4 unit is also isolable with your CH unit. Okay, similarly suppose you have Cp. Okay, then you have chromium. Okay, then you have CO whole 2. So for cyclopentadienyl it will be 5, for chromium center it will be 6, and for 2 carbonyl it will be 4. So again it will be your 15 electron. Okay, if you have cyclopentadienyl and nickel center, nickel metal, so that means what? 5 plus 10, also it is becoming 15 electron. Okay, if you have CH2 plus, so here also you will get 5 electron. Carbon is 4, hydrogen is 2, and plus means minus 1, you are getting 5 electron. So this is one category. Okay, so I can say this CH is isolable to each of this compound in this series. Okay, similarly I can write down CH2. So CH2 means basically you will get 6 electron. Okay, 6 electron you will get. So CH2 you are getting 6 electron, right? Okay, fine. So now write down, suppose you have FeCO whole 4. So how many electrons you are getting? Check. So for iron you are getting 8 electrons, and from 4 carbonyl you will get another 8 electrons. So 16 electron. Okay, then suppose you have chromium CO whole 5. So from chromium you are getting 6 electron, and from 5 carbonyl you are getting again 10 electrons. So again you are getting 16 electron. Suppose you have this Ni CO whole 3. Okay, so from nickel center you will get how many electrons? 10 electrons, and from 3 carbonyl you will get 6 electrons. So again 16. Okay, nickel means what? 3d8 4s2. So 10 electrons in total. Suppose you have this Cp, cobalt, and then you have carbonyl. So from Cp you will get 5 electrons, cobalt will give you 9 electrons, and CO will give you 2 electrons. So again you are getting 16 electron. Okay, sulfur is directly equivalent, because sulfur has 16 electrons. If you have CH3 plus, that is also equivalent to 6 electron, and if you have CH minus, this carbon ion, so that is also equal to 6 electrons. So this is another category. Okay, this is another category. So this is the first category, you have CH, and this is the second category, you have CH2. Okay. Clear? Any doubt?
Yes.
Clear, right? Okay, CH2 is done. Now write down CH3. Okay, so CH3 is basically what? 7 electron. So that will be equivalent to, okay, in home basically you will check. I am just writing down the units. MnCO whole 5. Okay. Then suppose you have CO whole 4, that will be also isolable. Suppose you have this cyclopentadienyl FeCO whole 2. Okay, so 5 electrons from here, 8 electrons from here, and 4 electrons from here. So 5, 8, 13 plus, yeah, 17 electron you are getting from here. Fine. Now suppose you have CH2 minus, this is also fine. Okay, so this is your CH3. Next, suppose you have CH4, so here you will get 8 electron. Okay, and for CH4, suppose you have this NiCO whole 4. Okay, suppose you have this FeCO whole 5. Okay, suppose you have chromium CO whole 6, and another thing you have CH3 minus. Okay, so these all comes under one category: CH4, NiCO whole 4, FeCO whole 5, CrCO whole 6, and CH3 minus. Okay, so we are starting from where? We are starting from CH, CH2, CH3, CH4. Clear? Any doubt? Any doubt?
No, sir.
No, right. Okay, another thing I forgot to write down. Write down here for only carbon. Okay, so if you have carbon, so that means you have 4 electrons. So basically you already know that will be also equivalent to BH, because this has also 4 electron. Okay, suppose you have FeCO whole 3, you just check here, you will get a 14 electron. Okay, chromium CO whole 4, here also you will get 14 electron. NiCO whole 2. Okay, CpCO, and another one will be your CH positive charge. Okay, so in all these examples you will get basically 14 electrons. Okay, so just check it. Understood? Any doubt? Done, right? Okay, now let's see some questions. So you guys will do it now. So I have shown how to do it. Okay, now you guys do. So suppose you have this iridium CO whole 3. Okay, here you have also iridium CO whole 3. Here also you have iridium CO whole 3, and this side also you have iridium CO whole 3. Okay, now connect all the metal centers to each other. Okay, connect all the metal centers to each other. Okay, done. Now they are asking what, that ErCO, that's iridium CO whole 3, this is actually isolable to what? Okay, they have given four options: CH2, CH, okay, CH3 or NH2. Tell me, this iridium CO whole 3, only this unit, this is isolable to what? This is isolable to what? Do it easy. Okay, this is not difficult at all.
CH.
CH, right? So basically if you see here that you have iridium and what, CO whole 3. So iridium you will get cobalt, rhodium, iridium, right? So 9 electrons from here, and from 3 carbonyl you are getting 6 electrons. So altogether you are getting 15 electron, and if you add carbon, hydrogens, you are getting 5 electron from here. So these are what, isolable to each other. Okay, now suppose next you have uh, osmium. Okay, then you have here CO whole 4. Okay, osmium, CO whole 4, osmium, CO whole 4. Okay, so now attach the metal center. Now they are asking, they are isolable to what? Cr2, option B is your Cr3, option C is your SiR3, and option D is your this SiR. Okay, do it.
Cr2, sir.
Okay, just wait for 2 minutes, huh? Wait for 2 minutes. Come back. Okay, fine. So this is actually what? This is osmium means what? Osmium means you have 8 electrons, and from 4 carbonyls you will get 8 electrons. So this is what? 16 electron you are getting. So that means it will be equivalent to what? Cr2, because carbon has 4 electrons, and from 2 alkyl groups you will get 2 electrons. So this is also equal to 6 electrons. So 16 and 6 becoming isolable. Fine. Now suppose you have this phosphorus 1, sorry, 1, 2, 3, 4, 5, 6. Okay, so this is replaced by what? Iridium CO whole 3. Option B is your FeCO whole 5. Option C is your Ni CO whole 2, and option D is your CpNi. Okay, do it. Yeah, so which option it is?
Option D, sir.
Option D. What about option A? Iridium is 9 and 6 electrons from 3 carbonyls. So this is also 15 electron. Phosphorus means you have 5 electron. You are also getting here 5 plus 10, 15 electron, right? So here both option A and D. Okay, both option A and D. Fine.
Yes, sir.
Okay. Okay. Now write down this question that common fragments among all three. Okay, common fragments among all three. So I am drawing some complexes here. Okay, this is the first compound you have. This is the second compound you have. And this is the third compound you have. Okay, so these are the three compounds you have. So you have to just mention what is the common fragment among all these three complexes. What is the common fragment in all these three complexes? That you have to find it out, identify. Okay, do it. So what is the common fragment here in all these three complexes? So see, here you have iron and this cyclopentadienyl, right? So if I consider only this, 8 electrons from here and 5 electrons from here. So in total you are getting how many electrons? 13 electrons. Now if you calculate this, if you consider this only, so for manganese you will get 7 electrons from manganese center, and from all these 3 CO you will get 6 electrons. So 7 plus 6, again it is equal to 13. Okay, and from here, so 2 to 4, and titanium will be what? Titanium has 4 electrons. From 2 carbonyls you are getting 4 electrons, and the cyclopentadienyl you will get 5 electrons. So if I consider this whole unit, one cyclopentadienyl ring, titanium metal and both the carbonyl, okay, then you are getting here 13 electrons. Okay, so that means these are the common fragments in all these three complexes. Okay, clear? Clear?
Yes, yes.
Okay. Okay, just a minute. Huh? So this thing is done. Now suppose I have this. Okay. Fe5. Okay. CO whole 15 4 minus. Okay. And you have B5H9. Okay. So they are asking these two are what? Clozo, nido. Okay. Option C is your arachno. And option D is your clado. So find it out. What are they? How to find out? So you have this complex Fe5CO whole 15 4 minus, and here you have B5H9. Okay, so for this B5H9 you can easily do it. Okay, so what you will get? B5H5 whole 4 minus, right? So basically it is your what? Nido. So now check for this complex. Okay, check for this complex what you are getting. How to check? How to check this one? So first of all you find out total electron count. First of all you find out here total electron count for this compound. Okay, so how to do it? 5 into 8. Okay, carbonyl you have 15, so 2 into 15, and 4 minus means you have to add 4, right? So 40 plus 30, 70 plus 4. So how many electrons you are getting? 74 electron. Now find out PEC, polyhedral electron count. So that will be what? Total electron count minus what? 12 into n, right? So total electron count is your 74 minus 12 into how many metal centers you have here? 5. So 12 into 5. So what you are getting? 74 minus 60 is equal to what? 14. And what is the third step you have to do? PEC divided by 2, right? So if you do it, 14 by 2 is equal to what? 7 you are getting. So n value is what? What is your, how many metal centers you have initially? 5. So that means n value is 5, and now you are getting n plus 2. So what is it? What it is? Clozo, nido, arachno, what? Nido, right? So this is also nido. Okay, so they are nido to each other. And if one transition metal like fragment like this, or transition metal complex is becoming nido or clozo with the same of your main group element, okay, main group metal, so that times they are becoming what? Isolable. So you can write down, therefore if both of the things you are getting nido or clozo, okay, so you can just conclude from here that therefore they are isolable, they are isolable to each other. Okay, they are isolable to each other. Clear? This thing clear? Any doubt?
Yes,
How
sir.
to check? How to check your this clozonido, arachno? Suppose they are giving two different things. One is your transition metal complex, another one is your metal complex. So metal complex you just do it easily, because if they have give you some boron derivative or carbon derivative, it is very easy for us. But for transition metal you have to find out by this way. Okay, so first of all you calculate total electron count, then find out polyhedral electron count, then find out PEC by 2 value, then check what you are getting. Okay, then you just match. Okay, okay, now this is the last question we have from this isolable topic. So write down that which one of the following metal fragments DN, M, L, M, yeah, is isolable with CH. Okay, so which one of the following metal fragments DN, MLM is isolable with CH? Okay, option A they have given you D7, ML5. Option B they have mentioned D8, ML4. Option C is your D9, ML3, and option D is your D5, ML6. Okay, this question is from your GATE exam. Okay, this is your GATE previous year question, so try to solve it. And they have mentioned clearly one thing, that L is equal to bidentate ligand. L is equal to bidentate ligand. So that is the information they have given. Okay, now tell me which one is correct. Done. Which option it is?
C, sir.
Huh?
Option C, sir.
Option C, correct, option C, correct. So CH means you have 5 electrons from here. So if you see D7, so that means you have 7 D electrons for your transition metal. So 7 from your metal center, and ligand is bidentate, so it is donating 2 electrons, right? So if you have 5 ligands, so that means ultimately they will donate 10 electrons. So it is becoming 17. Here it will be 8 plus 8, so it will be 16. Okay, here it will be 5 plus 12, so again it is your 17. And if you see here 9 electrons from your metal center, and you have 3 ligands, so each donating 2 electrons, it is becoming 6, 15 electrons. So option C. Okay, that is the correct answer. Okay, good. So we are done with this isolobal concept. Okay, next day we will start the carbonyl chemistry. Okay, so basically that is important, metal carbonyl complexes. Okay, that we will see in the next class, because we cannot start today, we don't have enough time. So it's better to start a new topic in the next class, in a separate class. Okay, and sorry for the noise, actually some that conference is happening here. Okay, so yeah, lots of people coming, and that's why this is happening. Okay, so just manage for today's class. I hope from the next class it will not be there. Okay, any doubt?
No, please.
Any doubt? Sampriti, any doubt?
No, doctor.
No doubt, right? Okay. Nayana, any doubt?
No, sir.
No, right? Okay, fine. Okay, that's it for today. Okay. Okay, bye. Thank you.
Thank you, sir.
Thank you. Bye.